About kind of way.
You're funny, Mr. Murphy.
This weekend, our son, we're eating dinner. We're up in the Dells. We're having dinner. He goes, "I got a joke for you." He's 6.5. He's first grade. What do you call a cow with no legs? Ground beef. He lost it. That was the funniest thing he's ever heard in his life. He just had to go. He's like, it's great getting ground beef because the cow's on the ground. So he was just hitting his table, and we're like, yeah, that's right. So it was nothing better than 7-year-old humor. So. Which one? Yeah. No, I did that one. Someone else told me the cow on the roof, top sirloin.
What do you call it? What do you call them?
Horribly inappropriate. Funny, but inappropriate. I do not condone making fun of other people's moms.
Wait, okay. We went caving this weekend, and on the bus trip back, Mr. Petrov was talking about how his wife's mom just died, and like some kid turned around and was like, "Wow, this conversation is deep," and another kid turned around and made a mom joke.
Anyway, so what you guys did last year with circles is that you wrote the equation. You wrote the equation of any circle as this: x squared plus y squared is r squared. Okay. A lot of times, it depends on where you're at. This is for when a circle was centered at the origin. So you have an r value of 3. If you're centered at the origin, you have an r value of 3. The equation of that circle is just nothing more than, well, x squared plus y squared equals 3 squared, which is 9. And that's how you write it. You're done. You're centered at the origin with a radius of 3. Done. Okay. The other part came in, though, is when you started to write the equation as soon as you started to shift it. And I know you guys all did this last year, bless you, in 10-7, if I'm not mistaken. Okay. The shifted version of a circle is your x minus h, quantity squared, plus y minus k, quantity squared, is r squared. And what do you think h and k stand for? H and k is your center. And r is obviously the radius. Okay. These are very, very easy to work with. Let's see, so x minus h quantity squared plus y minus k quantity squared is r squared. Is it June?
No, it's July. We got an odd jump.
Anyway, so what happened here was you could say that write the equation of the circle that has the center of -3 and 4 and a radius of 6. So if I want to write the equation for that, I know my h and k, I just substitute in.
Oh, I already messed up.
Oopsie daisy.
And what do I have to rewrite 6 squared as?
36.
Bless you. 36. Now, one of the things that I've always been pretty lenient on when you're writing these things out, most people just direct substitute right away. If you want to write equals 36 without having to rewrite it, that's cool. That's fine. If you wanted to square 6 right away and write it down, that's fine.
Wait,
That's it.
wait.
I can make this more difficult if you like.
Can you go up a little bit?
What's that?
Can you go up a little bit, please?
You knew I was going to do that. Remember, your center is h and k, so if it's -3, 4, that means it's x minus a -3, plus the radius x plus 3.
Yay!
Okay. The other thing that we'll do is we'll ask you to identify the center. I know sometimes it'll say graph the circle. Let me show you how to graph a circle. It's difficult. So I want to graph this and identify the center and the radius.
Oh no.
So my center is at what's my radius? Okay. Now, bear with me. This next step is ridiculously difficult.
Yeah, that was difficult.
All right. Okay. Let's find the center. Now, in order to figure out how to mark out your radius, my radius is just 5. Can't I just walk left 5, right 5, up 5, or down 5? That's all you do.
If that's really what you want to do, then.
It's kind of pointless, isn't it? One of the things I might ask is to give me ordered pairs on the circle. So that might I guess to do that, but like I said, you're just counting up, left, right, and down the radius. That's all you have to do.
That's
yes,
really
sir.
difficult.
Yeah. I'm not going to ask. Those are the only ordered pairs you can get that are clean. I mean, you can get the other ones, but we don't know how to do that yet. Yeah, you can make triangles. It is very, very, very simple. So let me show you the stuff that makes things a little bit more difficult, because that's how I am.
Yay.
Ooh. Yep. So we're going to go back and complete the square to classify it. One of the things that we do in here is that we classify the conic. In order to do that, you're going to put it into that standard form. You're going to complete the square and write it out in terms of h's, like the grouping h's and k's. The problems that I've been giving you for each of these sections, well, the first one, the parabolas, I give you just parabola problems. Obviously, today I'm just going to give you circle problems. Tomorrow I'll give you ellipse ones and so on. But eventually, by middle of next week, you'll be figuring it all out on your own. How do I write the equation and what do I have to do? And it all stems from having to complete the square a lot. So, when we complete the square, when you have two square terms, you're going to group the x squareds and the x's together, y's together all on one side, and then you move the constant over. So here I'm just going to put the x squared minus 4x plus blank. Add in y squared minus 2y plus blank has to equal positive 4 because I added over. And how many blanks do I have to put in? 2. Plus blank plus blank. Okay. And it's just a matter of completing the square twice. That's really all there is to it. Okay? Really all there is. So half of negative 4 is negative 2. That drops in the parentheses. I squared, what am I adding to both sides? There's a plus sign between them. Half of negative 2 is negative 1. Drops in parentheses. Square it, and I add what's your center? What's your radius? 2, 1, and 3. Good. So your center is at 2, 1. The radius is 3. That's basically what I'm looking for you guys to be able to do. It really isn't all that complicated. It really isn't all that complicated. There will be a little trick here about the differences between a circle and an ellipse. What I want you guys to see is that the circle equals some number. And there really is no fraction here. Now, if I do this, what does my fraction on the right become? 1. Now, what's going to happen here, to be able to distinguish between an ellipse and a circle, is that the circle gets the same number for its denominator. An ellipse will have 16 and 9, 25 and 60, something along those lines. Okay? These values, which we'll come to find out are called A and B tomorrow. If it's a circle, these will be the same. If it's an ellipse, they'll be different. That's how we're going to be able to tell the difference between a circle and an ellipse. That's more for tomorrow than it is today. Okay, more for tomorrow. Let's write the equation of a line that's tangent to the circle. At 2, 3. So this point 2, 3 is on the circle, and we're going to write the equation of the line that's tangent. So we have to think about, what did it mean to be tangent to something last year? It touched one exact point, and when you're tangent to a circle, you are what to its radius?
Perpendicular.
Perpendicular, good. So if I want to be perpendicular to a radius, first of all, where's the center of this circle? Well, I'll let you write it down first. I kind of got ahead of you. Sorry. Smidge. It happens.
Gosh, Mr. Murphy.
I know. Yes. It has to. It's r squared. It just so happens that r in this case is the square root of 13. That's all. So when I'm looking at something like this, visually, this is what it looks like. You have a circle centered at the origin. You've got this point 2, 3, which is on the circle. Okay. And what we want to do is find the equation of the line that goes through that point that's perpendicular to it. Which means we have to deal with something called slope.
Oh, I remember how
Okay? Your slope, and I'm pretty sure Seb did these problems with you guys. To go from the slope of this radius, you went up 3/2, didn't you?
Yeah.
So my original slope is 3/2. What's perpendicular to 3/2? Very good. Perpendicular to that is -2/3. And what point do you need to go through? That one right there, 2, 3. So in other words, there's a little form called point slope form that you'll use.
No way.
I know, it's crazy, isn't it? Point slope is your first thing of H and K. Did you know that? Isn't that y minus k equals m x minus h?
Yes.
Bring the k over, y equals m x minus h plus k, where h and k. So here it's just a matter of substituting back in. So you get y minus 3 is -2/3, x minus 2, and write the equation then. I always like to get you guys to go back into slope-intercept form. Whenever you write an equation, go back to slope-intercept. The reason is that you've got a button on your calculator that says, da, da, da. No, it's y equals. Which is, oh, shit, slope-intercept. So distribute out. And now I'm adding 3 over, and since I'm adding to a fraction, instead of adding 3, can I add 9/3? You see what I did there? I'm adding fractions in my brain.
Good job, Mr. Murphy.
Thank you. And what's 9 plus 4?
21.
Please make sure you use a calculator. Remember, if you're using a calculator, hit the alpha y equals button, and it'll do the fraction stuff for you. If you type in alpha y equals 4/3 plus 3, it should come out with 13/3 because you're asking it to do the fraction version of it. Okay. That's really about as complicated as some of these things can get. Yes, ma'am. The equation of the line that's tangent to the circle through that point. And we did. Yes, sir.
Can't the radius be tangent to anything on the circle?
Because it's asking to be tangent through that one specific point.
Oh.
That's all. It's asking for that specific point. You're right. There's an infinite number of tangent lines, but that's why they'll say through a point blah blah. Okay. Yes, sir. Point slope? No, I always want you to. The good question. Can you leave it in point slope form? No. Put it in slope intercept. Always write your equations back into slope intercept form when you're done. Okay. And really, the only reason that I do that is because you've got the calculus for y. Okay. Yes. No, because I'll say write it into slope intercept form. So here's the deal. Write it into slope intercept form.
I'll write it in slope intercept form.
Then don't worry about it.
But it's still right. You're just changing the form.
Maybe.
Yes, you have a question.
I don't remember. Let's show you one that's more difficult. Which one is that?
Oh my gosh, can you give us an easy one to start with?
Could that not have been any easier? Gee,
Give us a confidence.
Let me show you the whole classifying when you have to worry about your coefficients when you're completing the square. The way that I'm going to set this up is a little bit longer of a way of doing it. You can, absolutely. But here's the thing, sometimes they're not all going to be divisible by 4, all right? And I'm going to show the long way of doing this because this is how it's going to work for ellipses and for hyperbolas. It'll always work for circles too. It's just, it's actually just 2 steps longer. It's not a big deal. Yeah, we're gonna do what we're gonna do here is we're gonna write the equation of the circle, we're gonna find the center, the radius, all that kind of junk. Yes, sir.
What happens if the coefficient of x squared and the coefficient of the y squared is
That's why I'm showing this method, because it'll work for tomorrow. Because if they're not gonna be the same, you're gonna wind up more than likely with an ellipse or a hyperbola. Yes, ma'am.
For the last problem, we just assumed that the origin was, or that the center was the origin.
You didn't assume it because what's your h and your k in this case?
0.
0. That's the idea. You could have been given any h and k really, and just you don't need the radius. All you need to know is the slope between the center and the point on the line, or on the circle. Excuse me. So I got to adjust for it. Now, like I said a second ago, if I'm going to write the equation of the circle here, it's going to be. I'm going to go the longer method because this will be easier for you to understand why we do it this way with ellipses and hyperbolas tomorrow through Friday through Monday and all that kind of stuff. So I'm going to do the same idea. I'm going to get the x's and the y's kind of grouped together, send the constant over to the other side. So I have 4x squared minus 16x plus 4y squared plus 4y equals 60. We are. All I did was I just grouped them and moved them around. I didn't do any of my plus blanks yet. Because the rule is when you're completing the square, you have to have that first term equal to what? 1. All right? Excuse me. So here's what we do. I'm going to take the 4 out of the x terms. I'm going to get x squared minus 4x plus blank. I'm going to do the same thing with the y's. I have a 60, but here's what I need you to pay attention closely to. Notice I factored out a 4 out of the x squared. When I complete the square here, I'd have to do, half of -4 is 2 squared, add 4 to both sides. If I put a 4 in here, I have to put on the other side a 4 times that blank. Same thing here. 4 times something plus 4 times something. This is the longer method of going it. Like you said, Bryce, in this instance, I could have divided everything by 4 and been done with it, would have been okay. But, like you were asking, Pope, what happens if the coefficients are different? What happens if one's a 4, one's a 9? And that's where I'm showing this longer method, because tomorrow, if you do the same process, it's going to work itself out. Okay? Yes, ma'am?
Can you pull 4 from the x and say if like y had like 3, so you pull out a 3.
Yes, and that would be more stuff for, and then you'll be looking at an ellipse or a hyperbola eventually. Okay? Yeah.
You got the 4 from dividing the 2 and
Yeah. Remember, completing the square, you take out whatever the coefficient is, whatever that is. All right. Now you go through the method of completing the square. Half of -4 is -2. Square it, you get 4 here and here. So my term now becomes 4 x minus 2 quantity squared plus, well, what's half of 1? Half. So it's 1/2. Square it, what's 1/2 squared? 1/4. I'm adding 1/4. Okay? So here I get 4, and then it's y plus 1/2 quantity squared equals, well, 60 plus 16 plus 1 is 77. This is the idea here where, since we wound up with the exact same values in front of the coefficients, or excuse me, in front of the parentheses, we know it's going to wind up having to be a circle. Okay? We know it's going to have to work. But here's what I want you to see. What do both of these guys have in common? The 4. So I can factor out the 4. And again, I'm showing you guys the long form of this so you understand what's going to happen. Now, how do I move that 4? Gotcha.
why don't you take the 4 from the other side? Are you supposed to always divide like that whole equation?
We are. I just haven't got there yet.
Oh, sorry.
Okay. All I do there is I'm showing the reason why this is going to work, because these guys both have that 4 in common. I basically just GCF'd it.
Okay.
All right? And now I divide both by 4, which gives me x minus 2 quantity squared plus y plus 1/2 quantity squared equals 77 over 4. Which gives you a center at 2, -1/2. And what's your radius? Root 77 over 2. Remember, this is where you guys will mess up. Your center is easy. 2, -1/2. 77 over 4 is the r squared, which means r would be the square root of 77 over 4, which is root 77 over 2. Okay. Yes, this is worst case scenario because you have some really crummy looking radius, but it doesn't matter. Okay, that crummy little radius is more than 8, less than 9, so your radius is 4.5-ish, 4.25-ish. What's 8 squared? What's 9 squared? 77 between 81 and 64. It's closer to 81, right? So it means it's probably more than 8.5. So 8.6, 8.7, half of 8.6 would be 4.3. So 4.35-ish. Check it. I wonder what it is. 4.3. No.
It's like 2.1.
What did I say? 4.35? It's called approximations. Close-ish. Okay? Yes?
Would we ever graph this?
Sure. And this is a great question. How do you graph this? Okay? This is a great question. If you have a center at 2, -1/2, and you have a radius of root 77 over 2. Well, if I'm going to graph that and I want to list my 4 ordered pairs, you'll be surprised at how easy it is. There's my center, 2 1/2. Now, if I'm going to go and mark the vertical to that, what do I have to add root 77 over 2? Am I adding it to the x or the y if I'm going vertical? The y. So this ordered pair here would be 2, comma, negative 1/2 plus root 77 over 2. This one would be 2, comma, negative 1/2 minus root 77 over 2. See what I'm getting at here?
Yeah.
No, I'm not picking a random point, I'm picking the exact point. I approximated, it's 2 and 1/2, 2 comma, negative 1/2. I just put it where I thought it was.
No, like the point up.
Oh, yeah. There,
Just putting it
yes, that's,
somewhere.
but notice I'm labeling it.
Yeah, but you're labeling.
Yes, sir.
What's the little dot?
Here?
Yeah.
It's just the place, the spot that it's at.
Oh, it is. Oh.
Okay. And now if I go to the right, am I changing the x value or the y value?
Excellent.
So it's going to be 2 plus root 77 over 2, comma, negative 1/2. And then this one would be 2 minus root 77 over 2, comma, negative 1/2. We're going to have a lot of weird points going forward. We'll have a ton of them. Bless you. But that's basically all it looks like. You don't have to give me the right answer. You don't have to figure out what is the exact value, because that is the exact value. I don't care what it is simplified out. What's the point? Right, DeJounte? Okay, just wondering. Okay. Questions? Okay, do these.
Vito wants to know why.
What's up?
Vito wants to know why.
Why what? Hmm?
So we have like 2 minutes assignments?
It's 2 sections. Remember, this is the regular, and then that's the shift.
Oh, yeah.
Okay? So, like I said, I'm kind of mixing and piecemealing a couple of things together here and there. Okay? No, why waste paper?
Come on, Dave.
Yeah, you know, the environment's way more important
Yes.
than that stupid math.
What do you want?
Could you put them up there?
You ask a lot.
I know, I'm sorry. I didn't bring my book today. I'm sorry, Miss Murphy.
It's just
Wait,
you shaking my head.
Wait.
Yeah, I'll put them up there in a second.